Hey guys, today we're going to make a LED blink using an Arduino Uno. Now, this is, so it's already blinking now. I already have it set up, but I'm going to show you how I did this. So, let me just first turn this light off so you can see it blink a little bit better. So there we go. So I have this lamp facing directly onto this. So there we go. All right. Anyway, so this is a relatively old board. I've had this for years, and they still sell the Arduino Uno, but they sell newer revisions of it with slightly differences. I think they added like one more pin on the end or something like that. But this is pretty close to what you would get now if you bought it. And you power it on with this old USB connection. So with a port like this. So I had this old cable I had to pull out of an old box where I keep old cables. But so I was lucky to have that, and basically and it has a regular USB port on the other end. So for power, you basically you can either plug a power adapter in here or just power it from this. This is how you actually flash the program onto the Arduino. So I flash it over this USB cable, and the device is also powered from that. And so you'll notice few things I should point out here. We should start by looking at the pins, and well, I should put this at a different angle and try not to block the light. All right, so if you can, wow. All right, yeah. So if you can see there, this is the red cable is going to ground, and yeah, let me turn it like this. You can tell it. There you go. See, that's going to the ground pin, and the blue cable over here is going to digital 13. And you'll notice that two LEDs are blinking. There's one onboard LED that's blinking right here, and there's a LED on our breadboard over here that's also blinking. So which is kind of nice. So I believe the reason this LED is blinking is because it's tied to pin 13. But we'll look into that later. But basically, you could run this test if you didn't have a separate LED or you didn't want to mess around with any of these wires or anything. You could run this program and test this out just with the board. So you'd only need this board, plug it into this USB cable, flash the program onto it, and this LED will start blinking. Now, if you want to add an external LED, this is how you do it. So, and I'll show you the code in a second, or yeah, but anyways, the way I wire this up, it's really simple. You just need the jumper cables here, and the LED, and you do need a resistor. So you're gonna want that, and let me see if I can get the colors on this. It's not coming out because of the lighting. Maybe if I grab another angle here. Yeah, it's hard to make out the colors on this resistor. There we go. All right. So there we go. It's just basically red, black, and brown. But basically it ends up being a 220 ohm resistor. And the reason you need a resistor is because if you were to plug this LED in directly without the resistor, it would just pull too much current and just burn the LED out. Supposedly very quickly. I've never tried it. But yeah, basically you do need this, and the more ohms, the more resistance the resistor provides, the higher the ohms, the fainter this LED will light up. And you don't want to, you want to limit it enough that you won't overpower this. So there is a certain limit for that. Again, this is well within that limit. And let's see, what else could I say about this? So that's pretty much it. We're going to try a few other things with this in a minute, but let's take a look at the code. And I would normally do a screen capture, but I'm basically just going to point my phone at my computer screen, which is horrible, and I apologize in advance. But the code is so incredibly simple. It's literally like 5 lines that I wrote, plus like, the function headers and stuff. But I'm going to point my phone up there and just explain it in like 5 seconds or so, or close to that. So here we go. Here is my computer screen, and it looks bad because I'm recording a screen with my phone. It doesn't actually have those waves on the screen, but you see you have in your setup function, this runs on start, when you power on the device, and it sets pin 13 as an output pin. And then this loop just runs over and over forever. And we're going to set, so you basically set pin 13 to high or on, then you wait for 1 second, then set it to low, which is off. And then you wait 1 more second, then go back to the beginning of the loop, set it to on, wait a second, off, wait a second, and that repeats forever. So you notice that's in milliseconds. So 1,000 milliseconds is 1 second. And we're doing pin 13 here, and that is the pin that we looked at right over here that we're plugged into. So we're telling it to, turn pin 13 on, wait a second, turn it off, wait a second, and so on. So that's what's going on here. And I should also talk about how a breadboard works. Let me talk about that for a second. If you happen not to be familiar with breadboards, and if you're watching this video about how to make a LED blink, there's a good chance you might not be familiar with breadboards. But basically, you'll see these the two rows on the end here with a positive and negative sign, and the blue and red line there. So those basically, all the pins in this one row are all connected, and all the pins in the next row are connected. So in the same thing on the other side here, that works exactly the same way. Now if you look at the the pins in the center, they, instead of being connected going this way, they're connected going that way. So the way this circuit works is you're going to have your first pin coming in from the blue cable. This is coming from pin 13 on the Uno. So this comes into here, and you'll see this, it basically goes down this way. So everything in this, I guess call it a column based on how we're oriented, that connects to putting both of these pins in here will cause this cable to be connected to this side of this leg of the resistor. Now this other leg of the resistor is now connected to the positive pin on this lead, and then the negative pin on the lead is, see, that's one column over. That connects to, that's in the same column as the red cable, so that connects it to that red cable. Basically, putting things in the same column will connect them together. There's like a little conductive thing underneath there that connects everything in the same column together, and everything on these rows. These rows would get connected together. These columns are connected together. So that's basically how that works. And I should mention. So I'm not going to pull that lead out, but here's another different colored lead, and it's basically exactly the same except a different color. So you'll notice the legs on the lead. One leg is longer than the other, and the longer leg is positive. So and we're feeding into that from the resistor. So anyways, I don't know if I can get a good look at, if I can. There we go. I think my camera, will this focus? No, it doesn't want to focus just on the lead, if a little bit. But you'll notice inside there's a, I want to force this to focus. This is one thing that just frustrates me about this. All right, there we go. We can kind of see that in there. No, we can't. Yeah. Let me see if I can really get a good view of this. All right. Anyways, the big side, it's basically, well, you can tell based on the shape of the metal inside the lead, which is positive and which is negative. But it's probably faster and easier just to look at the legs of the lead, and unless you pulled this off of an existing electronic component. But you can kind of see in there the negative side is going to be it's going to be a little bit bigger inside there, and it's going to be on top. All right, there we go. See that? So the negative side is like a little bit bigger, and the positive side is underneath it, and it's a little bit smaller, and there's like a gap between the two. Anyways, that's a terrible explanation of how LEDs work. I could have probably gotten a better picture of that and just talked about the picture, I guess. But anyways, let's plug this in parallel just to do it, just to have two LEDs in here. And maybe this will just illustrate how breadboards work a little bit more. If I can do this with one hand. There we go. Now we have two LEDs on the breadboard blinking at the same time. However exciting that is. Anyways, there we go. Two LEDs blinking. So that's all fine and great. Now, let's say if we were to unplug this this blue cable from pin 13. So I'm actually holding my camera, which is my phone, and I'm going to plug this in right here into pin 7. Now, this is where I probably should be screen capturing, but I'm not going to. I'm going to try to do this really quick. All right, so and with one hand. So 7, and I apologize for making you watch me do this way. So here we go, another 7. There we go. Let's verify it, and we are going to just click this button. All right, so I didn't mention this before, but when you want to flash this code, you just click this button to upload it, and it will flash it to your device. You'll see some stuff at the bottom saying what's going on. Done uploading, I guess. So there we go. We flashed it to our device, and you'll notice. All right, so you'll notice our LEDs are still flashing again. And you might say, well, nothing happened. I mean, actually, when I had moved this cable, they stopped flashing. I probably should have, I don't know if I focused the camera on it for that. But basically, when you move from 13 to 7, it stops flashing. So we just update the pin that we're writing to here. And then all of a sudden, it just, it starts flashing again. So the other thing, interesting thing to point out here is the onboard LED. It is not, it's right next to that little thing, the little L there for LED. That LED there is not blinking anymore. It was blinking before. So that LED is tied to pin 13. So when you have output going out on pin 13, it also lights up that LED. So that's just an interesting little feature. So if you pick a different pin like 7, it's going to, it's not going to light up that onboard LED, and it's only going to do these guys. So say if we put this pin back on 13, notice 13 is not blinking on the onboard LED will not blink, and neither will these two LEDs. So if we went back here and we just change that back real quick, just change it back to a 13 and rewrite. There we go. And now it's back to how it was before. Onboard LED is blinking, and the two other LEDs are blinking too. So there we go. That's pretty much what we would expect. Worth noting, basically when you plug this thing in, the only issue I ran into, I should show you this real quick, and it would probably be worth again doing a screen capture. But anyways, you want to make sure the correct board is selected, which it was already selected by default. You want to make sure you select the port. So neither of these were selected, and all I had to do was go and click on the one that was. It recognized my device, but I had to go and actually click on it. And after clicking on it, before I clicked on that, I would hit upload and it would just fail. So I clicked that, just had to check that little checkbox and hit upload, and it works perfectly. So that's pretty much it. I'm not going to cover installing the Arduino IDE, but that was incredibly easy, and you can basically just click the install, just run the installer basically. And actually, one thing worth noting, I shouldn't say you just click the installer. I'm running this on Linux. Now this works exactly the same. The actual tool here will work the same whether you're running Mac OS, Linux, Windows, or whatever. But it's worth noting that I'm running this as root. I had issues actually. The other issue I had uploading was it was giving me a permission error, so it didn't have permission to access the port running as a regular user. So this is running on Ubuntu Linux. So I just ran the system as I'm running the IDE as root right now, and that gives me permission to actually write out on the port to this device. So there might be a way around that so that you don't need root permission, but for the time being, I'm using root. I mean, I'm not logged in on my desktop as root, but I used sudo to get root access. So I ran this IDE using sudo. So that's the last thing I think I wanted to mention. So that's pretty much everything I wanted to talk about with this device today. There's this little button down here that resets it. Press that button and it resets it, and it basically just starts doing the same thing almost immediately. Yep, so this is the Arduino Uno. And there's not a whole lot else we wanted to cover today. Well, one more thing before I leave. I would like to let me turn the light back on for this. I'd like to point out that there is, right next to the ground button, you'll see there's a 3.3 volt and a 5 volt button. So, so for both of those voltages, this resistor will provide enough resistance that you won't burn out the LEDs and you won't be overstraining them. So if you don't want it to blink, you can basically pull this pin out. Instead of having that on pin 13, pull this jumper cable out and just stick it in over here. And now these two LEDs will not blink. Instead, they're going to stay on just indefinitely. They're just getting 5 volts of power, limited by this resistor only. Now you'll also notice that this LED over here is still blinking. So whether or not you have something plugged into pin 13, the LED that's tied to that pin is still going to blink no matter what. And basically, this pin down here, the 5 volt pin, is just a convenient way to get 5 volts running over to your LEDs. Now I'm going to pull this out. So it just, regardless of the code that you're running or what you flash to the device, that's basically what it does. So I'm going to pull this out. I'm going to keep the light off. I'm going to pull this thing out and stick it in the 3.3 volt. And these should be slightly dimmer. You can barely tell, but they are more dim. Let me unplug that and stick it back in the 5 volt. See how those glow? On the camera, those look like almost white. Looking at it with my eyes, I can see it's more like red and yellow. It clearly looks like red and yellow on the top of the LED, but on my camera it looks like it's just glowing white. Now I pull this out and stick it into I stick it into the 3.3 volt. It's a little dimmer, and you can kind of make out the colors a little bit more. It's not a huge difference, but it's a little bit of a difference. Let me see if I could. There we go. Yeah, all right. So when I focus on the LED specifically, it doesn't look. So you can see the colors a little bit better when you focus directly in on the LEDs. So it adjusts for that, but still not perfect. It looks different with my eyes. It's what I'm seeing on the screen is not the same as what I'm seeing with my eyes. Now if I pull this out and focus just on this LED, I'll bet I can get it to show up. Yeah, not quite. It's still going to show up as white on the top. With my eyes, the whole LED is red for me. But anyways, I'm just rambling. So yeah, if you haven't stopped watching the video at this point, yeah. So thanks for watching. Give me a thumbs up. If you have any questions, comments, criticism, anything you want to say at all, just leave a comment down below. And click if you want to see more videos like this. Hit the subscribe button. We have a lot of other more interesting videos. Like I'm gonna pan over here, and so you'll notice I have all sorts of junk laid out on my desk at the moment. But I have this whole kit. I actually bought this for the Raspberry Pi. But I have all sorts of little components and stuff that we are going to be testing out. And if you look in here, I have all of this stuff, and I have like stepper motors, and so we have like stepper motors we're going to be playing with, and all these sorts of devices. And we also have a few Raspberry Pis. Here's my resistor pack with 3 different types of resistors. Here's the resistor codes, which I should talk about that before Yeah, so this is this resistor pack that came with this kit, and I did another video specifically about unboxing this kit, but it comes with the 220 ohm, the 1K ohm, and the 10K ohm resistors, and there's a little resistor code. This is how you tell, how many ohms a resistor is and what resistor you need. This is how you identify them, and those three types came in this kit, but I mostly bought this kit to work with Raspberry Pis. So we're going to be doing more work with the Arduino Uno and probably some other Arduino models, but we're also going to be doing a whole lot more work with the Raspberry Pi. I have a few different models of Raspberry Pis, and I've ordered a few different more single board computers. I've ordered like I ordered a few interesting things that I have coming in the mail, so I'm going to do like unboxing videos for those, and then I'm going to start testing those out the same way. First video for each of them where I'm going to make a LED blink, and after that I'm going to do pretty much anything I can come up with them. I'm going to test them out in every way I possibly can. But yeah, I have a lot of interesting projects coming up. We're going to be doing things like we have sensors like this. Like you've probably seen robots that people have built with sensors like this on them. We're going to be using like keypads, powering this. This is still in the wrapper, but we're going to be powering LED displays and servo motors and all that sort of stuff. So if you find this interesting, hit the subscribe button for more content like this, and hit the little bell icon so it'll let you know when I put out a new video. And also worth mentioning, all of that code that that little snippet of code that you saw, I'm actually going to post that on my site. So if you check the link in the description, you'll find a little write-up about what I did here, and you will also find I'm going to put that snippet of code on my site, so you could just copy and paste it off of my site. I pretty much just lifted that from Adafruit. So they had a tutorial on how to do that, and I basically took the useful parts. They had like pages and pages of stuff, so I just basically copied that bit of code and looked at how they laid out the circuit. So I have a much more condensed version of this, but I'm going to have that linked in the description. And if you're looking for where to pick up this board, also I'm going to have a link. I'm going to have an affiliate link in the description for that. So yeah, if you want the code, just look at the description. Look at the links in the description. Yeah, just wanted to make sure I didn't forget to mention that. And as always, hopefully you enjoyed watching this, and that's it for today.